Hello everyone, morning. I'm Michael Foord. This is my colleague Simon Davy. We both work at Canonical. I've worked there for about 4 years, and we were colleagues for most of that in the same team, working on some of the Django web application and services that Canonical uses, specifically the single sign-on and the payment service. But for the last 6 months, I've been working on a project called Juju, which is written in Go, so I'm no longer a Python programmer, at least not professionally. I still work on the Python core from time to time. And Simon has been working on getting the applications that we have internally at Canonical and deploying those with Juju. So today we're going to tell you a bit about Juju, about why you ought to be using it, and give you a quick demo of some of the things it can do. So the actual talk is called To the Clouds. And because we're talking about the clouds, get ready for an awful lot of buzzwords. One of the things I'm hoping to do, the term the cloud has been the subject of an enormous amount of hype in recent years, and you're probably all thoroughly sick of hearing about it. I'm hoping to rehabilitate the term a bit and showing you why deploying to the cloud is a powerful thing to do, even if you think you really don't want to. So we're going to start with a brief, potted and mostly wrong history of the cloud. And we'll start with Google. This is one of the, on the image here, this is one of their original servers from their early days. And they made a decision that at the time was quite radical, that they were going to deploy their services to cheap commodity hardware instead of to big iron mainframe servers. And that allowed them to scale very quickly. They could just add new machines into their cluster and get scale very rapidly and much more cheaply than their competition. And they built this fault-tolerant platform that enabled them to cope with the fact that their machines individually weren't as reliable as the big iron servers, but they could build on top of that a system and a platform that was reliable, and that they eventually made available as the public cloud, their platform as a service app engine. And the next step on from that was Amazon, who built infrastructure for running a huge retail website. And that was slightly different. That's what became known as infrastructure as a service. And it essentially just provided a whole host of virtual machines that were running in the cluster. And that was their cloud. And when they made that available publicly to developers, they became the dominant cloud player. And that's because their cloud, it just provides the, here you have a machine, deploy to it paradigm. And developers, Devops like that, system administrators like that because they know what to do with it. They know what to do with a machine. And modern public clouds include Amazon EC2, HP Cloud, Microsoft Azure, and quite a few based on OpenStack like Rackspace. So some of the benefits that deploying to the cloud provides, the problems that it solves include dependency hell, resource underutilization, and hardware management. And on top of that, if you have automated deployments, you also get easy scale out and rapid rollout, rapid deployment of new services, easy scaling and the rapid deployment of new services. I don't know what your processes are like if you're not already deploying to the cloud, but how quickly can you deploy new services? And the way the cloud achieves this is it separates your deployment target, it separates your deployment layer from the physical hardware that you're deploying to. So let's have a look at a few of those problems I mentioned. The first was resource underutilization and conversely overutilization. So a simple example, suppose you're deploying a dev wiki, you need a dev wiki and an issue tracker, so you need a server. So you get a server and you put those two things on it, and you're using about 10% of its capacity. Or alternatively, the processes around getting new hardware and getting that sort of added into your network and provisioned and set up are so painful and slow that instead you just jam everything onto the hardware that you've already got. And then everything runs slow as treacle. The next one I mentioned was dependency hell. I don't know if you've ever been in the situation where you have a couple of applications and a couple of services that use the same library, whether it be a Python library or something else, but they use slightly different versions of the same library. So you have to make sure that those two applications don't live together on the same machine. And then if you have a whole bunch of libraries that they're using, you have to have this sort of matrix calculation of maybe which machines can we put our services on. Or alternatively, you make sure that everything is using the same version. And then you have to, when you want to upgrade to a new version, you have to upgrade all your applications and do the rollout in lockstep. Now, of course, all Python libraries take great pains with backwards compatibility, so that's never actually a problem in practice, right? But I've been in the situation at Canonical where we've upgraded an application to use a new version of a library to take advantage of some of the new features it provides, forgotten that we've got another application on the same server that's using it, and damn, we have to do an emergency rollback because we just broke the other application. Now, you can, one way of solving that problem is using virtualenv as a deployment tool, but then you've given yourself a security problem because you have the same library in several different places on the machine, and they're in non-standard locations on the file system. So your system administrators and your Devops and your ops teams don't tend to be a fan of that solution. Or you can put them all on separate machines and you're back to resource underutilization, or my machine can go to sleep. Obviously talking too slowly. Or you can deploy each application and service to its own virtual machine, which provides an isolated environment where you can very tightly control the dependencies for each application. And the final benefit I mentioned, hardware management, which is fairly obvious. Because you've separated your physical hardware from your deployment layer, you can easily provision new machines without necessarily having to add new hardware, and you can take physical machines out of the cluster for repair or for upgrade without having to shut down running services. And that's a great advantage. So of course, if you're already running your own servers, you may feel that you not only don't need the cloud, but you don't want it. You can get some of the advantages that I just described from manually managing virtual machines on top of your machines, but wouldn't it be great if there was a framework that did this for you, that managed the virtual machines, that provided dynamic server management and allowed you to add new machines or take machines out either temporarily or permanently. And these days, that means a private cloud, and a private cloud probably means OpenStack. There are some other interesting technologies out there. There's a competitor to OpenStack called Eucalyptus, and there's a very interesting canonical technology called Mars, Metal as a Service, that gives you the dynamic server management, but directly with bare metal. But typically, a private cloud means OpenStack. OpenStack is one of the biggest things that's happening in the Python world right now. It's absolutely huge, both in terms of the amount of code, the amount of people using it, and the functionality that it provides. And the great news for Python developers is that there are an awful lot of people who will hire you to work either with OpenStack or on OpenStack. So I mentioned that we get the most benefit out of the cloud where we're able to do automated deployments. And a key principle for being able to do this is treating our servers as cattle rather than pets. Now pets, they have names. Do you give your servers names and choose the names in your company? You care for them lovingly by hand, you tend them, and when they get sick, you spend time, effort, and money on making them well again. Cattle don't have names, they have numbers, and when they get sick, you shoot them, and you get another one. You should be able to tear down and reprovision your application servers with single commands. You ought to be able to scale out and add new units of your servers or change the dependencies and the relationships with single commands. And that's the key to being able to do automated deployments. And I'm going to quickly flick to my notes because I had something more to say here. Right. So the advantage of infrastructure as a service, which has generally beaten platform as a service in the marketplace, is that it just provides this you have a machine paradigm. So when we move to the clouds, we leave a whole bunch of problems behind us, But we still have this problem of machine configuration and system administration. And I don't know about you, but as a developer, or even as DevOps, I don't really want to administer and configure machines. What I want to do is deploy services. What I want to think about is not machine configuration and administration. What I want to think about is the different parts of my infrastructure and how they're related and how I deploy them. There are a whole host of tools out there that will help you with machine provisioning. Chef, Puppet, Salt, just to name a few. Even Docker, although that's more about image-based workflows, but it's in the same family of tools. But they're still their focus is generally on the provisioning and the configuration, essentially the administration of individual machines. And there is an alternative which thinks about things slightly differently, and that's Juju. That's the project I've been working on and that we've been using a great deal at Canonical. Here, this image shows, it's in the Juju GUI, and it shows a deployment of a bunch of services. It shows the components and the relationships between them. And this is service orchestration. So some of the key benefits of Juju: you don't think about machine provisioning, machine configuration. You think about your services and you specify your deployments in terms of how your services are related. Also, cloud independent. It will deploy to Amazon EC2, it will deploy to Azure, HP Cloud, and also to LXC containers or KVM containers locally for testing, or it will deploy to Mars and to LXC containers on Mars as well. And the great advantage of being able to deploy to LXC is that you can create your entire production deployment and run it locally for testing, or you can run it on your CI, and then you can using the same configuration, using the same service description, you can deploy that to the cloud. And also, you're not locked into any one particular cloud. If you're a small startup and you're currently deploying to Amazon, you can use Juju to manage your deployments, and then when you get a bit bigger and you want a bit more control over your deployment environment, you buy a bunch of servers, you get OpenStack running on them. Juju is a great way to deploy OpenStack on those, by the way. And then you take your existing Juju deployment infrastructure and you retarget it to OpenStack instead. And again, for Python developers, this is particularly interesting. The way that Juju knows how to deploy services is through charms. Now, charms can be written in any language, but they tend to be written in Python, and there's a bunch of helpers to do that, and that's something we'll look at shortly. Where's that timer? I'm burning through the time. Yes. But even better, there's a whole host of charms already written for you for deploying common components. You will probably want to write a charm for deploying your specific application, the core of your business that knows exactly how to deploy that. You'll probably take an existing charm, like for a Django app, and fork that to do that. But for the other common pieces of your infrastructure, there's almost certainly a charm already written, and you can just take that and use that. Things like Hadoop, Elasticsearch, Postgres, MySQL, Ceph, and all these kind of things. Juju currently deploys Ubuntu workloads. We have a working prototype for deploying Windows workloads, and we'll shortly release that along with support for deploying CentOS. So it should be as easy as if you have to administer a Windows network and server system, Juju deploy SharePoint should just do what you want. Even though Juju deploys Ubuntu workloads, there are clients available for Windows and Mac. So at this point, I think I'm going to hand over to Simon, who is going to show us a deployment of a set of services based around a Django app, based around dpaste, and show us a bit around that. Would you like the microphone, Simon?
Give me a second, because this is...
So this is the Juju GUI. You probably can't see the URL very easily, but it's a 10.0 URL. This is actually running. This is for a deployment that we've already done. We didn't want to try and do the deployment live because it's quite network intensive, and I think that would just be tempting the.
It's failed like every other time because of the flaky networking.
Tempting the demo gods too much by depending on the network. So this is already deployed locally on my system there. And what we have a Django app which is dpaste, which is this thing. Unicorn as a subordinate charm. It means it's running on the same system. We could have had that specified in the configuration and in the charm for the main Django app, but because somebody has already done that, it's done a unicorn charm for us, it's easier to do it as a subordinate charm. So this line here means that it's running in the same unit as dpaste, and then we've got Apache right at the front. We've got a cache and a couple of HA proxies, a load balancer. We've got Postgres, and I think we've actually got multiple units of Postgres there.
We haven't now, but we will be shortly, hopefully. So this is like a typical way to deploy a scale-out service on any cloud. You've got Apache doing HTTPS termination. You've got HA proxy doing load balancing for your Squid cache, doing consistent hashing load balancing, so that the same URL goes to the same cache unit. And you've got HA proxy doing least connection load balancing to the dpaste app. Dpaste is a Django app on GitHub, and we just deployed it straight from GitHub using the Django charm, which is a generic framework charm for deploying, in theory, any Django app. If you have complexities, then you probably need to write your own charm, but for basic Django apps, it works well. And we have Postgres there at the top. Should point out there that what you're looking at here is not machines, but services. Okay? So if I click on, for example, dpaste, where am I? There. Max. How do I click?
It's probably just that slow.
Right. I have, like, seriously, I cannot use Max. Just click on that and the config should appear up there. It's probably just being slow.
I think it's just being slow.
So there could be a number of units under here. If we click on it, it'll show us how many they are. The reason why we do all this effort with HA proxy is allow us to scale each of these tiers independently. So I can just add units here, and this load balancer will take care of it. I can add units here, and this load balancer will take care of it. So, for example, what I was going to do through the GUI, but it doesn't seem to be responding. Or I can't click, one of the two, was add a unit to dpaste live, which was probably going to fail because of network. But it's easy enough. You add it in, the relation communicates to the HA proxy load balancer, adds the new IP and port into that load balancing, and it starts serving traffic. Likewise, the Postgres charm is just one unit. By default, it will start up in standalone mode. If we add a new unit to the Postgres service, automatically it will set up in hot standby mode with streaming replication. And
it looks like everything's up.
We could do it for the command line, which is what we use anyway. The GUI is a nice visualization tool, but for real work we use the command line. For example, you can just add 2 more units to Postgres and it will set them up as hot standbys. You can kill the original unit and it will automatically fail over to the new things. That's built into the Postgres charm. It's written by some of the core, the Postgres charm is written by some of the core Postgres people, so it's done right. And it's really very useful. I don't have to worry about that. I actually don't know how to set up streaming replication on Postgres myself. I've never done it, but I don't have to worry about it because the charm takes care of it, which is fantastic. So add unit dpaste, yeah? Go just far away.
Like, do I specify a number or?
No, just one. One is fine. Let's not tempt the gods too much. Just run it and it'll just have one unit, that's fine. So it's right now it's going away. This is running on LXC on Parallels on the Mac, and Inception. Yeah, what could possibly go wrong? It just needs a network connection to download stuff, to install packages and so on and so forth. So it's doing its thing, and it will add a new unit. And as I said, these relations are the key element. So one difference, we use Puppet a lot, and before we started using Juju, and one of the nice differences, you get this lovely sort of declarative high-level model of, have you got the config slide? So we can declare our entire stack as a YAML config, Here is, for example, the services in my thing, dpaste, the charm that it's using. I made some slight tweaks to the Django charm to add some features to it that I'll be merging up next week. You can specify constraints, how much memory, CPU, so on and so forth, and the options are the configuration that the charm exposes, which is all documented in the charm. And here's some other services. I'm using standard Gunicorn, standard Postgres, Apache with some enabled modules and a vhost template. Some services defined for the HA proxy, or the cache LB is a HA proxy service. The cache is Squid, and some configuration options, and I have it nice and visible. I can source control that and version it and diff it, and that defines my service. So for our services, we have files like this and source control that define it. Juju can deploy them, upgrade them, and so on and so forth. So it's a really nice way of declaring it. It's a higher level than writing Ansible or public scripts. We use a fair bit of Ansible in our charms, but so I quite like that approach. It works well. Have we got the anatomy of a charm slide? So you're probably wondering what a charm is. A charm is basically a directory full of files. There's some standard files, config.yaml. Off the bottom of the screen there's a metadata.yaml, which tells you what relations you support, and there's readmes. And then we have this hooks directory. And in this hooks directory, there are hooks that are invoked when things change in the relation. So the Django charm I'm using supports an AMQP relationship for adding Rabbit or some other server to run celery jobs, fairly standard. And that links to hooks.py, and what will happen is the Juju agent running on the machine, when a new relation is added, it will invoke the AMPQ relation joined hook, which can do what it needs to do. If something changes in the relationship, some of the configuration changes, it invokes the changed hook, and if the unit goes away, you kill it, or it just dies, because cloud is cloud, and then it calls the broken hook so you can handle that. That's basically how relations work. So it's quite a different model from statically declaring this stuff. It's much more kind of dynamic, and the units talk to each other directly, which is quite nice. So for things like Postgres, if I relate to a Postgres unit, it will create a database for me. I can tell it what I want the name to be, create a user randomly and a password randomly, and pass that back to me in the relation information, which in this case I would stick in the Django config file, and away you go. It's rather nice.
The advantage of the relationship model is we tell Juju that our application dpaste is related to Postgres. Then when we need to scale out our service, we do add units 5 or add new units through the GUI. And because we've already established this relationship between our application and Postgres, Juju knows that when our application comes up, it knows it needs to be connected to the database for us, and it does that for us.
Yeah, so it's a very different model from a lot of the other tools out there, which tend to fire up a machine and go, I don't know what I am, and use some form of service discovery. Michael was talking about that yesterday with his Docker talk. Go, oh, I'm machine ID, so-and-so, and service discovery goes, oh, you're a web server number 5. And then you contact Puppet and say, hey, I'm web server number 5, and give me nice stuff. So it's a slightly inverted model where Juju creates the machine for you and goes, you are web server number 5, and it goes, okay, I know all that, and I have this charm, and I just run the charm, and everything works. So charms are a really nice modular way, and as Michael said, they're available online. So the charm store is where all this stuff is, and you can download it and share it and fork it and use it. It's all open source, it's all reviewed. There's a full-time team dedicated to reviewing charms and building up a CI infrastructure about automated testing of charms and gating on them. So there's a whole bunch of examples. We also have bundles, which are like what we've got here, a whole stack. So there's like an OpenStack bundle. You can drag and drop the entire of OpenStack and deploy it. You'll be waiting a while, yeah, especially if you run it on LXC on your laptop. But actually, we use Juju at every level of our corporate engagements to deploy stuff. So typically, an OpenStack deployment will look like that. Will look like we install Ubuntu on one machine. We use Mars, the service Michael mentioned. We deploy Juju on that machine. We deploy Mars on Juju. Then we use the Mars to deploy OpenStack with Juju, and then we use Juju Workloads to deploy on top of OpenStack. So there's a blog post recently where we deploy Cloud Foundry. So Cloud Foundry is charms. The Cloud Foundry people have written the charm, so you can use Cloud Foundry on top. So you can have Mars, IaaS, PaaS, and then an open source PaaS app running on top of the Cloud Foundry, all running based on Juju, which is a bit insane, but you can do it. So yeah.
I think we're out of time. So thank you very much.
Any questions? One in the front.
I have 3 questions, hope you don't mind. The first one is, I just saw this the fab file in there, and I saw Ansible.py. Is Juju compatible with are these charms compatible with Ansible and Fabric?
So, that particular charm is uses Ansible and fab file to help you manage it. It doesn't need to, and it's being ripped out in the branch upstream. It was from the early days when it was experimenting with running about. You don't need it. However, there is, Michael mentioned the charm, the helpers library. There's a charm helpers library, which is in Python, and is usually included in every charm. That has Ansible integration. We use that heavily. So we use Ansible to do the heavy lifting, the declarative state things on our machine. We don't use the orchestration aspects of Ansible. We just use the modules that set up files and deal with the machine, and it's a lovely handler mechanism for firing and triggering events and things like that, which you can do in Python, but Ansible works. And of course, Ansible is Python, so we can customize it ourselves very easily. So, yeah.
Because Juju is about service deployment and orchestration, you still have to get things up and running on the individual machines. So it's not unheard of for some of the charms to use tools like Chef and Puppet as a way of achieving
or Docker.
Right. Okay, thanks. Second question. What's the difference between units and charms? I didn't quite get that.
So the charm is the
blueprint for
directory structure.
Maybe blueprint for the unit, I guess.
A unit is a unit of a service, and it's a unit is typically running on a virtual machine. So you have 3 units of Postgres, and the Postgres charm tells Juju how to create the Postgres units. And normally there's a one-to-one correspondence between units and machines, where the machine is perhaps an LXC container. You can tell Juju, deploy a new unit of this service into this machine. So you can sort of subvert that, but yeah.
So units are both services and machines?
No, there's services, which are the higher level concept, which are composed of one or more units. The charm is what enables those units to function. So when a unit is spun up, it gets a copy of its charm, and then the agent invokes the hooks to get it to do what it needs to do, essentially.
A unit of a service runs on a machine.
Okay, so it's an instance of a charm.
Unit is the Juju term for instance.
Right, perfect. Thanks. And then final question is a bit, I don't know, why are there so many different terms for the same thing in deployment? Like, for example, you call this charm, Ansible calls this, I think, an action, and then in SaltStack you have states.
They're not the same thing. A charm is a different thing from an action, or Salt has recipes, Chef has recipes, Puppet has manifests. There are different terms, but a charm is very different to all of those.
Okay, so you did the right thing, but the other, I mean, I find it very confusing that all these different tools use different terms for more or less the same thing. So
I used Puppet for 3 years, and I still don't know the difference between a module, a class, and manifest.
Right. Yeah.
Does anyone? Figure that out through Puppet. All right, so we've got some next loads.
Thank you.
So.
More questions?
Thanks. Nice talk. I just wanted to take up the point that you made there, that systems like this, I've been recommended, I know Kapil, and I've been recommended using Juju for about, 4 or 5 years or whatever, a long time. And one of the things that causes me to resist is just the cognitive overload of learning this new system. Now, just now, you took a moment to explain that a unit is kind of an instance of a charm. If we are selling concepts like this, I think it behooves all of us to come up with simple models and express those simple models top down. I think very often we start off bottom up, and that gives us immediately that cognitive overload. So I think kind of roadmaps to understanding systems like this help to sell them and help people to actually go in and use them. And
there's extensive documentation on what unit
Yeah, and it's probably massive. And is there a lightweight overview of that?
Yeah.
Okay, cool. All right, well, thanks. Yeah, I love the concept, and I'm going to give this a shot. So, thank you.
Final question, anyone? Thank you very much, Michael and Simon.